So when we name compounds, we mentioned previously that the first decision that we have to make is the compound ionic or is the compound molecular? We then said if we decide that the compound is molecular, we have to decide, is it an acid or is it not an acid? To be an acid, there has to be a couple of conditions present. The formula has to contain hydrogen, and it has to be an aqueous solution. Additionally, there's generally a mention that the compound is an acid. If it's not an acid, then we're going to use the rules that we apply to what we call binary molecular compounds to decide the name of the compound. So we need to define what we mean by a binary molecular compound. And a binary molecular compound is just a compound which contains two different types of nonmetals, and these compounds are held together via covalent bonding, that is through the sharing of electrons. So water is a covalent or molecular compound, but it's also a binary molecular compound because there are only two types of atoms present, oxygen atoms and hydrogen atoms. Now, molecular compounds don't exist as crystals where there's an extended array of connections between a very large number or approximately infinite number of particles. Instead, how they exist is as discrete molecules, smaller bundles of atoms held together via covalent bonds. But the important thing here in each of these binary molecular compounds is that there are only two types of non-metal atoms present. So when you write the formula for a binary molecular compound, the general rule of thumb is, but people break this all the time, is that the atoms are written in approximate order of increasing metallic character. And if you recall, the metallic character increases from the top right of the periodic table down to the bottom left of the periodic table. So from fluorine all the way down to francium. Now that can be a lot to remember, but the key thing is you put the lower group number first, but if you do happen to have two elements in the same group, then the one that is lower down in the group comes first. So there are some other rules for this, but we're not going to get too hooked up on that. So two nonmetals can combine to form a binary covalent compound, and the rules for naming binary covalent compounds, I just hiccuped when I saw that, are pretty simple. You give the name of the first element unaltered. So if we had something like this, we'd just write the beginning of the name CO, we'd just write carbon for the C there, unaltered. And then it says the second element in the formula is named with the root, but you're going to change the ending to IDE. So very much the same as what we'll be doing for anions. So the oxygen there is just going to become oxide. And then what we're going to do is we're going to add what are referred to as Greek prefixes to indicate the number of atoms of each element present. So in order to finish off the name of this guy, we need to know what is the prefix that goes in front of each of these atom names. So to be able to do that, you're going to need to memorize the Greek prefixes. And so we want you for general chemistry to know the first 10. They continue obviously above 10. Now, this isn't a complete waste of time. It's kind of fun to just drop these into, everyday conversation. Hey, do you think you could get me a hexapack and a dodeca of eggs from the supermarket? It's kind of fun. So you just kind of have to go ahead and memorize them. Now, don't confuse these with your Latin. They're not, it's mono, not uni, it's di, not bi, and it's tetra, not quad, and so forth, right? Just be kind of like aware of that there is a difference there. Okay, so once you've got those, then it's pretty simple. There is one other little rule, is that if there's one of the first element, you don't have to give it a mono. So in our previous example, we had the first element unaltered, the second element gets changed to, the ending gets changed to IDE, and then we give Greek prefixes for our elements, but we don't need one for the carbon, because it's the case where there's one of the first element and then there's one of the second one, so it becomes mono. Now, I don't know why, but in English the double O in the middle of the word is very rarely used, and so we tend to write monooxide as monoxide and drop the second O. It's just kind of a little quirk of the English language. All right, so name of the first element in each case, so phosphorus, there it is, and then name of the second element, change the ending to IDE, so that becomes chloride, and then Greek prefixes to indicate how many of each, but remembering that if there's only one of the first, you don't have to give a mono, so it becomes phosphorus, 5 of the chlorine, pentachloride. Okay, the formula and the name follow the same sequence of elements, so it's always first element, second element, first element, second element in both the name and the formula. Now, if the hydrogen is the first thing in the formula and they've made it clear that it's not an acid, so there's no mention of water, there's no mention of it being an acid, you're going to name it, you're just going to leave out the Greek prefixes. So this would become hydrogen chloride. Okay, and we mentioned that in the naming of acids video. So HF, if it's not actually behaving as an acid, it's not dissolved in water, and there's no one's mentioned it being an acid, is named as hydrogen fluoride. So for compounds that begin, molecular compounds that begin with H and they're not acids, you're going to just omit all of the Greek prefixes. Okay, so very simple, short video on naming binary molecular compounds. Hope you found it helpful.